Welcome to this new lecture on partitioning, and this is part of the module where we are talking about query performance enhancement techniques. And after looking at aggregation, we now turn our attention to partitioning, which is another very effective technique for handling huge volumes of data in a data warehouse. And it plays a very important role not just in improving query performance but also in terms of maintenance of the data warehouse, and it also helps in refresh cycle of the warehouse, as we shall see in today's lecture. So let me begin by giving you the motivation behind partitioning. So for that I have two very common examples that we are all aware of. The first one is about file system, and second one is about the cash drawer or the cash compartment at a supermarket, like when you go to the cash counter, right? So there is a cash counter or cash drawer, right, where currency notes are kept, right, and change is kept, right? So let me first talk about the file system or the file folder example. So here I give you one extreme situation that all your files, say on your desktop, say I am saying that all your files are in C colon. Okay, so once I say that, so all the files that you have, they are in one big container, C colon, right, or the C drive. Now what happens when you do this? Say, okay, so you suppose you create a new file and you create it in this, right? So you don't have to worry about where it is going, right? So you just put it in the C colon, right? So suppose you get an attachment in the email, right, and you download it and it goes somewhere here, right, and all your files are here. I'm just making a heap kind of a structure, right? So all your files are here, right? Now when you say, as I gave you an example, when you are downloading an attachment from the mail, you just dump it here. You don't have to worry about this. Now suppose I give you another situation where you have, right, say this is your C colon, and then you have made some subdirectories in this. So one subdirectory is about your courses that you are doing probably in this semester, right? And then you have something about your projects that you are working on currently, something about your personal, say some personal data or personal files are here in this, and some other things, some like you have organized your stuff like this, like courses, projects, and within courses again you have subfolders like say data warehousing course or some data mining course or some other courses that you are doing. Similarly, project wise you can make subfolders, and similarly personal, you can put your pictures in one, movies in one, right, and so on, and something else somewhere in another subfolder like this. Now when a new file comes, right, so what you need to do, you need to figure out whether it is related to courses, whether it is related to projects, or whether it is personal. Then again you have to figure out, say suppose it is related to courses, then you have to figure out whether it is related to data warehousing courses or not. If it is so, then you put it here. So you bring the new file in this folder, right? Now so this takes time, right? You need to figure out where you need to, what is the proper place for a particular file, right? And similarly, when you want to retrieve this file, say you said that okay, this is I want the test paper of data warehousing, which I attempted last week. So you know where you are supposed to find it. So you directly go to the data warehousing folder and retrieve that. Consider the same situation in this in the first setup, right? When you don't know where your file is, so you have to search through all these files to figure out where is the test one paper of data warehouse, right? So retrieval is difficult, is cumbersome, right? Okay, so in data warehousing it is all about retrieval. So you want to make the retrieval efficient. So what can we do about it? So let me give you another example. Let me close this video so that yeah. So now let me come to the second example, that is of a cash drawer. So I'm sure all of you have seen this, right? So now I again give you a situation where this is a cash drawer, right, of at the cash counter, right, and I put all 100 rupee notes here, all 5,000 rupee notes here, all 1,000 rupee notes here, 50, 20, 10, 5, right, then all the coins, not separately, right, all the coins like 10 rupee coins, 5 rupee, 2 rupee, 1 rupee coins are also here. So all this is jumbled up. Okay, so what happens, like if somebody gives you exact change, right, say okay, he bought a product for 12 rupees, right, so he gives you 12 rupees. So what you're doing is you are taking the 12 rupees from the customer and just dumping it in this cash drawer. You don't care, right, where it is going, right, so there's just one compartment and you're putting your money there, right. Okay, so collecting the money becomes easier, right. As in the case of file system, the downloading of file becomes easier. You don't worry or you don't care about where your file is going, right, or getting stored. So same thing here. Now suppose a customer buys a product for rupees 64, right, and he tenders a 100 rupee note to you, right. So you dump the 100 rupee note anywhere, so that is not a problem. But now you have to give him 36 rupees. So what you do? You are stifling through the notes frantically and trying to figure out 120 rupee note, 110 rupee note, 5 rupee coin, and 5 rupee coin and 1 rupee coin to return 36, right? So this return of money, return of change takes longer, right? And again, it is the same as retrieval, right? You wanted to retrieve 36, but it takes you longer. And now let me show you a cash drawer, right? So you can see here now, once I show you this, okay, let me clear the annotations now so that you can see. So now you see here that different currency of different value is kept in separate compartments, right? So there is something called as compartments, right? Or I call them as partitions, and these are for coins, different remuneration coins, and these are different remuneration currency notes, and these are like some collection of coins, like one packet of coins, right? This is typically you see in US or in any other European country, right? Although in India also now you see these kind of drawers. So now what happens? Say somebody gives you $100, right? And he buys say for again 64, and you have to give him 36. So you know that this is $10 note. So you pull out 3 from here, 1 5 rupee from here, so 3 from here, 1 from here, and you give $1 coin from here, right? So you're done. Okay. So this retrieval becomes faster, or giving out the change becomes faster, right? And same thing happens in data warehousing. Okay, so what happens is that if I talk about a fact table, so all your records related to the fact table, all fact table records are kept in a single compartment, and that is your fact table. Now suppose this fact table contains 5 years data, and you are interested only in a particular month's data, say 2014 month of January. Suppose you are interested only in the data for this month. So what you need to do? You need to write an SQL, or you need to write with the appropriate filters, which will only take this much data, right? Or which will only get data corresponding to 2014 January, right? But you'll have to stifle, or you'll have to work through all the records that are there in the fact table. So this is very expensive, right? So what could I have done? Now imagine the same situation where I have compartments or partitions for each month, right? Say for example, say if it is 5 years data, so suppose I have 12 into 5, 60 partitions, okay, one for each month. So suppose this is the partition for January 2014, and likewise there are other partitions. Now when I want, so I'll change the color of my pen so that it is, so I'm interested only in this data, right? So I know somehow that there is a partition which corresponds to my January 2014, right? So I can just take all the records in this without applying any kind of filter and retrieve all the data that I want, right? So this way I am saved from looking at these other data records that are there in the fact table. So I'm only talking about this particular partition, right? So this again somehow similar, analogous to indexing, but this is much more effective than that. So as I go forward in this lecture, I'll give you more specific examples of how partitioning is supported in a data warehouse environment. And a lot of commercial RDBMSs support partitioning, the concept of partitioning. So in my lecture, I'm going to refer to Oracle's support for, so all versions of Oracle's after 9 I have extensive support for partitioning. So I'll give you examples using that, or maybe the SQL statements which I use, right? So let me clear the annotations. Okay. So it improves performance, mainly the query performance. Ease of management. I'll talk about what is that. So ease of management basically refers to, say I was mentioning about refresh cycle of a data warehouse, right? So when new data comes in, say suppose my refresh cycle is monthly, so every month I bring in new data, right? So I have monthly partitions like this, right? And when I bring in a new partition, say suppose I want to, at the end of this month, say which is May, say 2015, I want to bring in this data, and I want to take out the oldest month, say that was, say for example, January 2012. That was the oldest month, so this month, 2012, sorry. Okay, and I want to bring in this data here. So I have not enough space that I can bring in May 2015 data without expunging the oldest data that I have. So it is a requirement that I remove this January 2012 data, right? So what I'll do is, and I have created these partitions, I can run a query which will say drop partition January 2012. Okay, so when I do this query, or when I run this statement, SQL statement, right? So it allows me to drop this. Now suppose I wanted to drop this data corresponding to January 12 in the absence of partitioning. So then I would have issued a query, say delete from sales fact, right? Sales fact table, where month is equal to January and year is equal to 2012. I would have issued a query like this, and then from the whole of the fact table, every record would be tested against this condition, that whether this data or whether this record belongs to January and 2012 or not. And if yes, I would delete that record, right? Suppose this is there, right, and this is there, so I remove these records. So I'll have to go through the entire fact table to be able to do this, right? And here I am working with what is called as DML statements, that is data manipulation language. So if you are familiar with SQL, I'm sure all of you are. So I'm dealing with DMLs, right? So that is data manipulation language. Whereas when I issue this command, drop partition January 2012, I'm basically dealing with, or I'm issuing what is called as DDL, that is data definition language. So how these two are different? I mean, SQL I mean, both of them are issued using SQL, that is fine. But DDLs execute and at a rate which is much faster than DML. In fact, they are an order faster than DMLs, right? So I am able to expunge the data of January 2002 using a DDL in case of partitions when I have partitions in my, I partition my fact table. But if I, in the absence of partitions, I have to work with DMLs, which are much slower than DDLs, right? So this is what ease of management is all about. And fact tables are partitioned with respect to dimensions. So it could be any of the dimensions, any, but we typically partition with respect to the time dimension, and I'll tell you why. And dimension tables may also be partitioned, but this is typically not done only in case of monster dimensions, right? Monster means very huge dimensions, like for example the customer dimension in a telecom company like Bharti, right? So where they have millions and millions of customers. So there you may have a reason to partition the dimension tables, but typically we partition the fact tables which contain the maximum amount of data in a data warehouse. And so partitioning, so there are two kinds of partitioning basically. One is the horizontal partitioning, and this is the main focus here, although there is vertical partitioning also, which is normalization, which you already know. And there is also something called as vertical partitioning. So I'll just tell you quickly about vertical partitioning, and of course about normalization. So when you do a normalization, right, so what happens is that there is a one-to-many, so if there is one record, so there is a one-to-many relationship between the the tables. But when you do vertical partitioning, right, so what happens is you partition it, say you remove certain attributes from here. So when I partition this, I get two tables of the same kind of depth, but with, say, columns like this. So I've just split it somewhere here, like this. Now when I split them vertically, so there is a one-to-one mapping between the records of the partitions. Okay. So the benefits of normalization you all know, because it allows you to save space. Okay. So what is the benefit of vertical partitioning? Vertical partitioning, basically what you do is you are reducing the length of the records. So when you reduce the length of the records, so what happens is that in the main memory, when you want to bring your data from the database into the main memory, right? So you know there's a concept of a block or a page which can fit only a certain amount of data, so which is typically 4 kilobytes, and you know that the memory is arranged linearly, right? So when I reduce the length of the records, I can fit more records into my, say, suppose this is the length of the record, so more records into a 4 kilobyte page, and that means less number of IOs. Okay, so that's the, so basically when I do row splitting, so this is what I'm talking about, this vertical splitting, we call it row splitting. Here I split a row and it helps in saving IOs, right? Normalization helps you in saving space. But our main focus here is on horizontal partitioning, so which comes in many flavors. So one is a range partition, so where you specify the range, say for example in time. So I can say that you create a partition for year-wise partition 2012, 2013, 2014, and so on, right? Hash. So here you have to just specify how many partitions you want. So suppose I say I want 5 partitions. So what it will do is so the hash function is actually not known to us, to the user, but if you define 5, so it will have an hash function which will create 5 partitions and will partition your data into 5 equal partitions, almost equal partitions. Then there's a list. Say for example I want to create so there are partitions like north, south, east, west, 4 regions of a country. Now in these 4 regions there are states. So you want to specify what states are there in the north region. So they may not follow any kind of order, or they may not satisfy any kind of ranges, like in case of time, which is linear, right? Or they may not, the states in a particular region may not have an alphabetical order. right? So what you need to do is you need to specify a list. So suppose I want to talk about North region, so I can say, okay, UP, J&K, Rajasthan, right, and Punjab, Haryana, and so on. So I can specify a list. So any record that belongs to these states would come under the north partition and so on. And then there is combinations of partitions of the above type. So I can combine a range with a hash, or a range with a list, or a hash with a list, right? And sub-partitioning is also allowed. So suppose I first created a partition with respect to say years, but then I can partition with respect to some other dimension, right? So that is all possible. So Oracle supports all these types of partitions. So there are some thumb rules, like we had some thumb rules when we talked about aggregation. So at no point of time there should be more than 500 tables in the data warehouse. So this is a kind of a recommendation, not a hard and fast rule, because experience tells us that if there are more than 500 tables in a database, the maintenance and the administration of that becomes very difficult. And I said earlier in my lecture that we generally partition with respect to time, right? So the reason is here. So do not partition on a dimension grouping that is likely to change within the life cycle of the data warehouse. Say, for example, product and location. So suppose I had partitioned my data, my fact table based on categories of products, right? Now tomorrow, you may say that I want to redefine my categories. And once I decide that, I will have to change all existing partitioning. And that is a very expensive exercise to drop the partitions and create them again. So I don't want to get into that. So I would not want to create partitions with respect to a dimension whose definition, right, is going to change with time. Similarly, location. So suppose there is a company which operates in 4 regions: north, south, east, and west, right? Okay, so this is west. Okay, so north, south, east, and west. Now they have one person, one manager for each region. But now they are seeing that after a couple of years of operation, they realize that this is too big regions. The regions are too big to handle, right? So they want to split them up, right? So they want to say that, okay, I'll have more regions, say north, south, west, east, right? So now they want to have a northeast region, right? Or they want to have west, northwest, or the southwest, and something like the southeast. So they want to break it up, and they also want to have a central region, right? So now all those records that are there in these 4 partitions have to be now moved again, or reshuffled along, or redistributed along the new partitions that you have created, which is a very, very expensive exercise. So it should be avoided at all costs. So that's why we partition only with respect to time, because the concept of time is never going to change. A day will remain a day, a week will remain a week, and a month will remain a month. So that's why we partition only with respect to the time dimension and nothing else. So advantages of partitioning. So let me clear the annotations. So faster access to data, so which I have discussed already. Easy support for data purging. So this also I've done discussed. Like if I want to purge the oldest partition data, I can do that. And parallel DMLs. So as I said, we'll be working with DMLs instead of DDLs, right? Okay, DMLs also. So parallel DMLs. So if there are different partitions, right, and I want to do some processing on them through DMLs, so each partition can be handled by a different processor, right? So that helps that facilitates in parallel processing. And backup of large tables, so that also becomes simple. So you have a fact table, right, and you have backed it up to the last partition. So when you add a new partition during the refresh cycle, so you only need to back up the latest partition. So backup of large tables is also facilitated by this, right? And this is what okay. So this is what we typically try to do. So there's a big sales fact table. You can see how many records are there, 500 million records. So I'll create, so this is a notional picture of partitioning. So I'll create almost equal size. It is not that each partition would have the same number of records like shown here, but this is just symbolic, right? It is just symbolic. So basically I'm saying that I've created 5 partitions out of this. And there are some very interesting facts, like how partitioning is supported. So what you have is that, so you had all your data in this table, right, in the sales fact table in this table. Now when you create this partition, suppose this is like with respect to years, so let me use some other colors. So that, say, suppose this is for 2010, 2011, 2012, 2013 and 2014, right? So I created these partitions year wise, and 2015 data is yet to come. So 2010, 11, 12, 13, 14. So I've created these partitions. So when I do this, right, so when I say that you create these partitions, so data from this table is distributed according to the partition definition into these. So the data physically moves to these partitions, right? So these are like tables. So how they are supported in so these are now real tables that are created. So when I'm using a solid line, that means these are real tables. So these are all real tables in the database. Okay, and what happens is that this, oops, sorry, okay, I'll have to do it again. By mistake I removed all the 10, 2011, 2012, 2013, 2014, and I have to physically move these records into these partitions. And when I do that, all of these are like tables, actual tables in the database, right? And what happens to this table, original table, because there is no data now, so it exists only as a virtual entity. So this becomes a virtual table or a virtual entity. Okay, so now why this virtual entity is actually kept? Because all my queries, like I discussed when talking about aggregation, that you are not aware of what aggregates are present in the database. Similarly, you are not aware of what partitions exist in the database. So you will always query, the user will always query the original table, that is the sales table, right? So the virtual existence of this table is very important. So how this virtual existence is maintained? So this sales table is defined as a view, which is nothing but a union of these partitions. Suppose this partition is P1, this is P2, this is P3, and this is a P5. So this is a virtual, this is a union of, I'll write it separately, union I is equal to 1 to 5, in this case Pi. So the sales is a view, which is nothing but the union. So any query that you have will come to the sales table first, right? And then it automatically goes through the metadata to so the metadata also plays a very important role. So I'll not be talking too much of metadata at this point of time, but I'm just tagging the metadata part here. So when we discuss metadata in the next module, you would understand all these things. So I'll revisit all these things when I discuss metadata. So, and all these partitions are directly available to you. So you can query any partition directly also if you want to, but the rule says that you should not, the user should not be aware of the partitions. So let us see what next. So this is what I've done. So partitions could be equal size, unequal size, so that is understood. So, okay, sorry. With respect to product dimension, with respect to location dimension, with respect to size, so I can do anything, but as I told you, We generally partition only with respect to the time dimension. And range partition is most commonly used, and the partitions are by definition non-overlapping, right? And so, for example, I want to create partition by month, so I'll give you an example, which is the exact SQL syntax. So let me clear this annotation quickly. So here you can see I'm creating a table sales range, and this I'm creating partitions at the time of creation of the table. Time of creation of table. I can do it later also, but say salesman ID. So this is one attribute, salesman name, sale amount, and sale date. And I'm saying I'm partitioning by range. So most the time partitions are always by range because you can specify the time ranges, and I'm doing it on the sales table. So you can see partition sales. So this is one name that I'm giving, right? This is February. So these are all monthly partitions that I'm creating. Then March and April, four months. So you can see how I've specified this. So this is the exact syntax, values less than toDate. So toDate is a function which converts any date format to any desired format that you want. And so this is how I do it. So you can see January means less than 1st February 2000, right? Then this is this partition. In this partition I'm saying less than 1st March, and so on, right? Okay, so this is how monthly partitions are created. So when I specify less than 3/1 of 1st March, that does not mean that January data would also be included. So this is the kind of support we get in RDBMS. So this is how I create my partitions. And this is another example which is similar. So clear the annotations. Okay, and since these partitions are created, they are physical entities, physical database objects. So I can do, so there is this metadata table which is called as user table partitions, and where table name is sales, I want to see that. So I'm running in SQL, select partition name from this, and this would give me the all the partitions that are there. So January, February, March, and April, and seeing the records in the partition. So I can query the partitions once I know the names of the partitions, like these are names, right? Okay, so I can give their names and I can see all their records. And now this is what I was talking about, the virtual entity. So here what is happening is when I look at the original table sales, I can always query this, right? And I'll get the union of all the partitions as the data. So what does it give you and what can you infer from it? So what you infer from it is that the virtual entity, right, is of the table that we have partitioned exists in the database, right? And you can always query it like you're querying any normal table. So it exists like a view, right? All of you are familiar with the concept of view. So that is what I have for partitions. So I'll give you maybe not a lecture, another lecture on this, but another module, another recorded lecture on this. But I'll definitely provide you with some of the features of Oracle, Oracle support for Oracle for partitioning. So I'll provide you with that sheet, and you can work with that. Try that on any Oracle RDBMS, right? So to see how you can create partitions, how you can see the partitions, how you can query the partitions, and what is this virtual entity, right? So with that, I wind up this lecture on partitioning. And the next lecture I'll see if I need to talk more about partitions, so I'll plan it accordingly. Okay. Thank you.